I'd like to share with you ideas and progress in the field of regenerative medicine and how what its implications are on an aging society. As we age, our bodies lose our ability to regenerate ourselves, to repair our tissues, to minor injuries, to continue a renewal process. Much of this has to do with the nature of Darwinian evolution. So we've evolved to live, we live much longer than we've evolved to live. So there's no selective pressure to change our bodies to continue to evolve once you live beyond, say, 2 or at the very most 3 reproductive generations. Patrick mentioned 100 years. That's about 6 reproductive generations. So evolution never dreamed of the possibility of us being this old. If we look at the process of development from the embryo to the fetus, there are just phenomenal morphogenetic processes that undergo there. So generation of new shapes, not repair, not restoration, not regeneration, but generation in the first place. Developmental biologists try to understand that. So some animals continue this regenerative process into adulthood, like the newt. You can sever an entire limb, it will regenerate just as though you never severed it in the first place. Other animals, unfortunately mammals, so us, don't possess such a fabulous regenerative capacity. So the myth of Pericles and Atlas, and Pericles had his liver chronically eaten by the eagle, yet he failed to die. That suggests, that, at least from the myth, that some tissues have a very substantial regenerative capacity. So a chronic regenerative capacity. Indeed, the liver does. So due to stem cells and the way that stem cells are differentiated and activated in the liver, it can regenerate tremendously. You can surgically cut away about 90% of the liver and the rest of it will grow back, regenerate very effectively. Other tissues in the adult body don't regenerate nearly as well. So for example, if we look in orthopedics, so in the spine and the hip, cartilage in the hip regenerates very poorly. The bones in the spinal vertebra, they also repair poorly to micro cracks. The intervertebral disc repair poorly. This leads to loss of mobility, to disability, to loss of lifestyle, and then economic costs. So scientists focused on stem cells and understanding of that process and maybe even using them as tools in regeneration. Stem cells, some derive from so-called adult stem cells from muscle or bone marrow. Others derived from skin and turned into what are called induced pluripotent stem cells, which can regenerate any tissue in the body. There's a lot of scientific focus on what surrounds the cell in the milieu, what signals these stem cells see that tell them whether to self-renew or whether to differentiate into other tissues of the body. So this is one of the keys to being able to exploit stem cells. So the stem cells have a capacity to differentiate into a number of cell types, nerve, blood cells, muscle, all cells in the body, depending on the details of what stem cell population. So the tricks are then, how do you control that differentiation process, and how do you stabilize it once the differentiation has occurred? One particularly interesting source of stem cells is the bone marrow. So mesenchymal stem cells, so-called mesenchymal stem cells that reside there. They reside in many connective tissues as well. And there are clinical trials ongoing now, good progress in being able to produce a number, you can see them, a number of cell types, of tissue types from those mesenchymal stem cells. So people try to understand how to do that, how to control mesenchymal stem cell differentiation into these different cell types. There are protein regulators called growth factors that tell the cell whether to form a muscle, whether to form a nerve. So these growth factors are being studied, and they can be used to supercharge, as it were, the regenerative capacity of stem cells in the body. So work from our own lab, for example, takes a hormone that's present in all of us, parathyroid hormone. It's used therapeutically to treat osteoporosis, and re-engineers the molecule to make it function locally in bone repair, to supercharge what stem cells do in the local site so as to have a protein-based therapeutic. The last 20 or 30 years has met with phenomenal progress in mechanical, electrical devices in restoration of function and degradation. So, for example, in hip or knee replacement. These have and will continue to have very important impact in our society. But the future few decades will focus on more biological approaches to supplement those mechanical approaches. We'll never be in the state where we take an old man into the fountain of youth and he crawls out as a young boy. That's not the goal. The goal is to take these people like us and to keep us functional more into our elderly years so that the 100-year-old is a functional 100-year-old rather than a cost incurring and not very happy 100-year-old. Thank you very much.
Thank you very much.